Derivatives of composite functions, the chain rule. So here, what was the composite function? Composite function is basically, it's written like this, okay? F of g of x, and this is equal to f of g of x. What does this mean? You basically put this g of x instead of x in this f function, okay? Maybe it sounds complicated, but you will understand better right now when we solve this example. But first, how we take the derivative of these functions. So these functions derivative, this is equal to, first you will take the derivative of f of g of x. Basically, you will take the derivative of f of x, and then you will put g of x instead of x, times you will take the derivative of this g of x. Okay, so let's look at this example. Here we have f of x is equal to 2x plus 1 to the power of 3. G of x is equal to 3x squared. So what is the derivative of f of g of x? So when we look at our formula here, first we need to find the derivative of f of x. Okay, so let's do that. The derivative of f of x is equal to 3 times this inside of parentheses will stay as it is. Okay, 3 minus 1, it's 2, times, I will take the derivative of the inside of this parenthesis, it's equal to 2. So this is equal to 3 times 2, it's 6, times 2x plus 1 square. Okay, so I need to also, now I need to put g of x, okay, instead of x here. So let's do that. The derivative of f of x when we put g of x instead of x is equal to 6 times, so it will be 2 times, instead of x I will put 3x squared plus 1, okay, to the power of 2. So this will be equal to 6 times 2 times 3x squared. This is 6x squared plus 1 to the power of 2. Okay, now we found this one. Let's find the derivative of g of x. So the derivative of g of x is equal to, when I put this 2 in front of this one, 2 times 3, it's 6, it's equal to 6x. Okay, so for the answer for our example here is equal to this one. So it's equal to this one times this one. So it will be 6 times 6x. It will be 36x times 6x squared plus 1 to the power of 2. You can use this way, or you can first find this one, okay, and then take its derivative. You will get the same result. Or let's do that. So how I find the value of f of g of x, instead of x I put g of x here in this f function, right? So let's do that. This is equal to, so it will be 2 times, instead of x I will put 3x squared plus 1 to the power of 3. Okay, now this is also equal to 6x squared plus 1 to the power of 3. Okay, now I can take the derivative of this, so it will be, this is equal to, so I put this 3 in front of this parenthesis, it's 3 times 6x squared plus 1, 3 minus 1 is equal to 2, times, I will also take the derivative of the inside of this parenthesis, which will be equal to, when I put this 2 in front of 6, 2 times 6 is 12, it will be 12x. Okay, so from here we will get 3 times 12x, it will be 36x. So inside of this parenthesis is 6x squared plus 1 to the power of 2. So you see, as you can see, we got the same result. So whichever way is easier for you, you choose that way and you will get the same result. Let's continue with this example. Here we have f of 4x plus 1, which is equal to x cubed minus 2x. So the derivative of f of minus 7 is asked. So in this kind of questions, before we start for this example, actually we know that when we have a function like this, for example, f of x, let's say, is equal to 3x squared plus x, okay? So we know how to take the derivative of this function, right? How do we take its function? The derivative of this function, we put this 2 in front of 3x, this is 6x plus 1, right? It's very simple. But what if we have a function like this, f of 4x plus 1? How can we take the derivative of this function? Actually, in this example, this should be written as the derivative of f of x times the derivative of x, okay, is equal to 6x plus 1. But since the derivative of x is equal to 1, we don't need to write it every time, okay? So let's go back to our example. On our example, here we have this function, f of 4x plus 1. So how we can write its derivative? So the derivative of 4x plus 1, okay, times the derivative of x, which here is 4x plus 1. So what is the derivative of 4x plus 1? It's 4, okay, and then this is equal to, and then we will take the derivative of this side, and which is equal to 3x squared minus 2, right? Okay, after this step, the question asks the derivative of f of minus 7, right? So instead of x, we don't put minus 7. Don't do that. What we do, we should first make this part equal to minus 7. And then after that, we will find the value of x, and then we will go put that value here in this part of equation. Okay, so let's do that. So 4x plus 1 is equal to minus 7. So here 4x is equal to minus 8. X is equal to minus 2. So now I can put this value instead of x. Okay, let's do that. So here the derivative of minus 7 times 4 is equal to, this is 3 times x squared. X squared is equal to 4. It's 12 minus 2. So here the derivative of f of minus 7 is equal to, this is 10, and here we have 4, 10 over 4, which is also equal to 5 over 2. Let's continue with the derivatives of trigonometric functions. So this is very important topic. So let's say y is equal to sine u. So its derivative is equal to the derivative of u times cosine u. And when y is equal to cosine u, the derivative of y is equal to minus the derivative of u times sine u. So here you take the derivative of the function also here, and then you multiply this by cosine u when you take the derivative of sine. Okay, so here the derivative of cosine is minus sine, the derivative of sine is cosine. Okay, so let's look at this example. Here we have sine 4x, the derivative of sine 4x. So first, you know that the derivative of sine is cosine, right? So I will write this cosine 4x, and I will also take the derivative of this 4x, which is equal to 4. Okay, let's look at this one. Here we have the derivative of cosine 6x. So I know that the derivative of cosine x is minus sine, so it will be minus sine 6x. And also I need to take the derivative of this 6x, which is equal to 6. So this is equal to minus 6 sine 6x. Let's look at this one. So here we have the derivative of cosine x minus 1. Same logic. I know that the derivative of cosine is equal to minus sine, right? So it's minus sine x minus 1. So I will also take the derivative of this function, this expression, which is equal to x minus 1. Its derivative is equal to 1, right? We only take the derivative of x, which is equal to 1. So this is equal to minus sine x minus 1. Let's continue with this example. In the first example, we have f of x is equal to sine 3x plus cosine x squared. So what is the derivative of f of x? So how we find this? First, I know that the derivative of sine x is cosine x. So the derivative of f of x is equal to its cosine 3x, and I also take the derivative of this part, which is equal to 3. Okay, 3 times cosine 3x. So here we have cosine x squared. So I know that the derivative of cosine is equal to minus sine. So instead of this, how we write its derivative, it's equal to minus sine x squared. Okay, and also I need to take the derivative of this part, which is equal to 2x. So this is the answer for our example. Let's look at our second example. Here we have f of x is equal to sine square 4x. So what is the derivative of f of x? So if this exponent, when this exponent is here, actually you can write this expression as sine 4x to the power of 2. Okay, this is actually the same thing. These are equal to each other. Okay, sine square 4x. But let's say if this exponent is here, of course you cannot write this expression like this. But since the exponent is here, you can actually write this as sine 4x to the power of 2. Okay, so now let's find the derivative of f of x. So it will be equal to, so here we put this 2 in front of the parenthesis. Okay, it will be 2 times sine 4x. Okay, I will take the derivative of inside, which is equal to 4, and I know that the derivative of the derivative of sine 4x is equal to cosine, so it's equal to cosine 4x. Now let's continue with tangent and cotangent. Let's say y is equal to tangent u. So the derivative of y is equal to the derivative of u times 1 plus tan square u. Okay, so let's say y is equal to cotangent u. So the derivative of y is equal to minus the derivative of u times 1 plus cotangent square u. Okay, so let's look at these examples. Here we have d over dx tangent x. So the derivative of tangent x. So when we look at our formula, it's u, the derivative of u, which is equal to here 1, because the derivative of x is equal to 1. So this is 1 times 1 plus tan square x. Okay, this is also equal to 1 plus, instead of tangent, I can write sine over cosine, right? So this would be sine square x over cosine square x. So from here, this is cosine square x plus sine square x over cosine square x. I know that the cosine square x plus sine square x is equal to 1. So this is equal to 1 over cosine square x, which is also equal to secant square x, right? So let's look at this one. Here we have f of x is equal to cotangent 3x squared. So what is the derivative of f of x? So here we will do, we will take this formula. So here we have minus the derivative of u, which is here 3x squared. So the derivative of 3x squared is 6x times 1 plus cotangent square u, which is here, is equal to cotangent square 3x squared. in this example we have f of x is equal to sine square 3x times cotangent 5x. So what is the derivative of f of x? So here we will use the product rule for derivatives, and as we said before, instead of sine square 3x, actually I can write this as sine 3x square. Okay, so it will be much easier for us to understand. So let's continue. How I take the derivative of this function? So how is the product rule? So let's say fx is equal to gx times mx. Okay, so how we take the derivative of this function? This is equal to the derivative of first one, okay, times the second one plus the derivative of second one times the first one. Okay, so let's do that. So here we have the derivative of f of x is equal to the derivative of the first one, which is here sine 3x squared, right? So I put this 2 in front of the parentheses, and after that it will be sine 3x, okay, and then times, now we will take the derivative of inside, which is equal to the derivative of this expression 3x. It's 3 times, I know the derivative of sine is equal to cosine, so this will be cosine 3x, okay, times, I also need to multiply this by the second function. Here we have cotangent 5x, okay, plus the derivative of the second one, which is cotangent 5x, right? So it's minus, so minus the derivative of this expression, it's 5, okay, times 1 plus cotangent square 5x, okay, and times, we will also multiply this by the first function, which is equal to sine 3x square. Okay, so let's rewrite this again. So this is all equal to 2 times 3, it's 6, 6 times sine 3x times cosine 3x times cotangent 5x minus, because it has minus sign here, so it's minus 5 times 1 plus cotangent square 5x, yes, times sine 3x square.